This recording is going to go over Lesson 6 in Unit 3, Fractions as Division Problems. And a lot of students don't think of fractions as a division problem, but we can represent the numerator and the denominator as the divisor and the dividend. So as you go through, definitely check out these models and repeat them as necessary so that students can see. Right here we have two friends. It says you and two friends, so that would be three people are sharing two granola bars. So how could you share these two among three people? And as you go through the lesson, it will model that and break them into thirds. So we still can't divide it by three people yet until we cut them apart. Sorry, I skipped that part. So after you cut them apart, they will continue to divide into thirds, and then each person would get two of the thirds. The same can be done with donuts and other models, and it kind of shows how we would have to divide things up before we could share them. Now this lesson does have a checkpoint so that you will have a checkpoint in the middle of the lesson and at the end, so it's kind of an adaptive lesson. Here's another example of how we can use word problems to demonstrate fraction division. It says Romulus used 3 bottles of olive oil. So he has 3 bottles, but he divided it among 8 tables. So he has 3 divided by 8. The next one talks about there are 6 families attending a banquet. The families equally shared 9 size loaves. So there's 9 loaves, but we have to share it with 6 people. So we have 9 shared by 6. So it looks like there's more loaves than there are families. So this can get a little tricky, but we have to think about the total and what we're dividing it by. We have 13 guests at the banquet want to equally share 4 jumbo jugs of water. So we have the 4, but we have to divide it by 13. And you'll continue to go through additional problems like that. You will also have fractions on a number line. This activity is really beneficial, and it kind of relates back to some of the things that your child may have learned in 3rd or 4th grade as far as where numbers go on a number line. And so after they model and show that things can be represented in different ways, so 1 is the same as 8 eighths, and then there was some other models that showed equivalent fractions, you will have the opportunity to place some fractions on your own. For instance, some are mixed numbers and some are improper fractions, but they both represent the same amount and are equivalent. So as we go through the tutorial, then you have the opportunity to click on different things, to select where the fractions would go and check your answer, and it starts off pretty simple, but then it gets a little more complex. What we want students to realize is that 4 means that it's divided into 4 equal sections. So we want one of the 4, we want the whole. Now we have a mixed number. We have a whole and 3/4. Then it gets even a little more complicated when the denominators are not necessarily the same. We can see that the sections are divided into 6, so plotting 5 6 is pretty easy. But then we have 1 and 1/3. So even though they're divided into 6, we need to think about where would it be if we divided it into thirds. There would be 1/3, 2/3, 3/3. So there's 1 and 1/3. And then 2 and 1/2. And as you progress, then you're going to get into improper fractions and even more complicated things with mixed numbers. So we can see they're all the same denominator, so that's easy. 11 thirds, we would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 thirds is the same as 3 and 2/3. So continue to practice those activities, and then it is time to go to the math activity book and work out some problems, and I'll head right there before we take the checkpoint. These problems are very similar to the ones that were just done in the practice sessions. It says a plumber needs to cut a 6-foot long pipe into 10 equal pieces. How long will each be? So we have 6, but it's divided by 10. So we have 6 over 10 would be our fraction. It also says to make sure that improper fractions are then converted and changed to mixed numbers like we did in previous lessons. There's several problems like that you will get to practice. And then down here, it shows, just like we did on the number line, what means the same as 3/7. Well, we have a seventh, a seventh, and a seventh. If we had a 7 over 7, that would be 1, 2, 3, or 3 wholes instead of just 3/7. Now we have an improper fraction. So we have more than 4/4. We have 5/4. So the answer would be C. So let's head back to the OLS and take a peek at what the checkpoint would look like. This is the first checkpoint within the lesson, and it is very similar to everything that has been done. It is basically plotting numbers on the number line, making sure that students are aware of the increments and what that denominator shows. If there's a 4, then we need to make sure the number line is divided into 4 equal pieces, not just 3. So paying attention to the numerator and the denominator is going to be critical for success on this checkpoint. So after you go through that checkpoint, you will continue to practice in the OLS. And then at the end, there is an additional checkpoint that deals more with number lines. You will also have directions within the lesson guide that will help you with additional tips and tricks on helping your child be successful with this lesson. Now I am going to go back and review this assessment just to give you a sneak peek of what the checkpoint will be. Different questions will be randomly generated for your own student, but this goes back to the word problems where it says Trevor had 4 small boxes of raisins to share equally among himself and 2 friends. What's important is when we have words like himself and 2 friends, that means there's 3. Even though we don't see that number 3, he has 4 boxes and he's dividing it by 3. We also will come into problems where there may be more than one correct answer. So it says choose all answers that are correct. Here we have a cement truck that holds 9 cubic yards of cement. The truck delivers all of the cement to 2 different locations. So we have 9 divided by 2. It could be written as an improper fraction, but we definitely want to convert that to a mixed number. 9 halves is the same as 4 wholes and 1 half. We would have 2 over 2 plus 2 over 2, 2 over 2, 2 over 2, 4 times to make 4 wholes and then 1 half. So there will be about 5 questions in this checkpoint and 5 questions in the other checkpoint. So I hope this helps you understand a little bit more about fractions as division problems, and then we're going to head into some additional lessons where we're actually multiplying a fraction or dividing a fraction by a whole number and a whole number by a fraction.